direct the Marine Geospatial Ecology Lab here at Duke University.
Awesome. Beth?
Beth Stiles, Fish and Wildlife Commission in Florida.
Gino?
Good morning. Gino Olney, coordinator for NOAA's Southeastern Caribbean Regional Team.
Welcome. George?
George Sedberry, NOAA Office of National Marine Sanctuaries, Southeast Region.
Welcome. Jacqueline?
Jacqueline Daly, NOAA Fisheries Habitat Conservation Division, Charleston.
Excellent. Jesse?
Hi, folks. Jesse Cleary. I'm a geographer in PATH's Marine Geospatial Ecology Lab here at Duke.
Nice. Mary?
Mary Conley, Southeast Director of Marine Conservation for the Nature Conservancy.
Excellent. Michelle?
Michelle Duval, North Carolina Division of Marine Fisheries and South Atlantic Council.
Roying? Did I lose you, Roying? Had you on there. Nope, I think we lost him. Bembu? You on mute? Okay, got to put a couple people on mute, struggling for mute buttons. That's okay. So we'll go ahead and keep rolling here. So quick. Go ahead.
Tom Oakey here as well, Victoria, British Columbia.
Tom, excellent. That was one thing I forgot to do. Check if anyone was on the phone and not on the WebEx yet. So awesome. Welcome, Tom Oakey.
Mary Trulia is also on with Florida Fish and Wildlife.
Oh yeah, you're still getting your. Mary.
Still trying to get on.
Still turning. Oh.
I'm here.
Okay. Good. So I guess we'll give.
You might want to check to see what browsers they're using. We found that the Google Chrome browser was having trouble with the WebEx. So if you use Firefox or another browser, it seemed to work really quickly.
No, there you go. So maybe Mary try Firefox or something else and see if that helps. Sounds like I know Pat and Jesse had trouble with that before. Yeah. All right. Well, we'll go ahead and get going. At least a few of the introductory things are hopefully while you're loading everything up. So quick introductions and just looking down the list. Pretty much everybody here at some level has been involved in some of the South Atlantic LCC indicator revision process and particularly some of the revisions and indicators in general. So the general idea, what we're here for today is, as many of you know that have looked at some of the recent indicators in the blueprint, there are certainly some opportunities for improvement. And the idea right now, we're on a 1-year update cycle on improving some of those indicators. So within the marine system, we're working with sort of 3 major indicators that try to capture the integrity of the ecological integrity of the system. Before we had a previous marine mammal and turtle index based on some of the older U.S. Navy data, sort of sightings per unit effort. It was okay, had a lot of gaps in survey effort, and so Pat and Jesse have been working on kind of a next generation, much improved version of this that should be ready in time for by the end of this year for us to potentially use as an improved indicator for the South Atlantic, and also might be particularly useful for some of the other applications y'all are already working on. So really, because there's a lot of detail in this, we're going to focus this call pretty much on just catching up to speed on some of the details of this modeling effort, give you a chance to ask some questions, and there's some lot of nice opportunities for kind of bringing in some lessons learned and building on a ton of work that's also going on in the Mid-Atlantic and the North Atlantic and bringing it down so it works in the South Atlantic as well. So with that, any questions before we start the overview here? All right, Pat and Jesse, take it away.
Okay, so we're going to try to go fairly quickly through an overview of the marine mammal modeling work that we've been doing. A lot of this work has kind of evolved over time. We've been developing models for marine mammals and sea turtles for several different agencies, and most recently we've been doing applications trying to prepare this data along with fish and seabird data for ocean planning processes in the Northeast and the Mid-Atlantic. So the first slide here, hopefully everyone's seeing these okay on the WebEx, was just a slide to remind us that we're talking about the South Atlantic LCC, and then the 3 indices that we just mentioned. And so we're looking at seeing if the work we're currently doing can be slotted in to help improve the marine mammal and turtle data for this region. So I mentioned that we're working on ocean planning, so I thought I'd give a little context of what we're doing because it's a rapidly moving field right now, and I think it's probably good for you guys to hear what's happening in other regions. Right now, my lab is leading what we call the MDAT team, the Marine Life Data and Analysis team, which consists of several partners. The Marine Geospatial Ecology Lab at Duke is the lead institution, and then we have 2 NOAA labs, the Northeast Fisheries Science Center and the INCOS lab in Silver Spring, that are dealing with the fish and seabird data. We started out in the Northeast and have been also doing the Mid-Atlantic as well. You'll notice on the left side where the map is, you'll see a couple names of other institutions there. Probably most of you are familiar with these. But in the Northeast, there's an Ocean Council, which is a standing body, the NROC, Northeast Regional Ocean Council. They're kind of the long-standing body that is organizing and aggregating data together and they're supporting a formal Northeast Regional Planning Body, which is separate from that. I think sometimes people kind of merge these things together because they work so closely together. In the Mid-Atlantic, there's MARCO, the Mid-Atlantic Ocean Council, and then there's also a formal Mid-Atlantic Regional Planning Body. In the Southeast region, we have the Governor's South Atlantic Alliance, which is the standing kind of ocean council, which is made from the 4 state governments. But there is no formal regional planning body set up at this moment, so it's the East Coast is somewhat uneven in the development of ocean planning work. So right now, we're looking at how we can stimulate more work in the Southeast. So the work we're currently doing, my lab is working mainly on the marine mammal and sea turtle part. We're going to focus on the marine mammal piece today. But I did want to let you know that we do have collaboration and are aggregating the data on seabirds and fish. The seabird modeling extends all the way down for most of the species down the Atlantic coast as well. So we actually have good coverage there. The fish abundance models and data is from the Northeast Fisheries Science Center. So and most of them are biological groupings. So for the marine mammals, looking at all cetaceans aggregated together or separating out, the baleen whales from the small dolphins, from the larger dolphins or delphinoids, sperm whales, beaked whales, but then also some regulatory breaks. So people would be interested in saying, which are the ESA, listed species. And then one that we put in here was a sensitivity one, which might be, what type of sound domain are the animals using? Are they mid-frequency, low-frequency, or high-frequency using species that may be sensitive to different kinds of perturbations? So there's a lot of different ways to think about this. So these are just ones that have emerged from our discussions in the Northeast and the Mid-Atlantic. So just to show an example here, we've got 3 maps now aggregating species together. So you have the dolphins, the baleen whales, and toothed whales aggregated together. And the big issue here is just that these things show very different geographic patterns, and it's a simple way to be able to think about aggregating multiple species together into these more biological taxa-related groups. The next one, one that we started doing a little bit of work on, this came up from work we were doing with NOAA on a project called the SET Sound Project, Cetaceans and Sound. And what we're looking at is trying to do some very crude first cuts at separating out species based on their functional hearing groups. And this is based on prior studies, so we just went and used kind of tables that were developed with different species classes. There's some potential overlap between the cutoffs for these, so this is, it's kind of a general classification, but we think that this could be an interesting way to be able to break out animals into these kind of functional types that may be more or less sensitive to different kinds of sound perturbations, especially with different kinds of new management conditions that come up. So it's just a different alternative way to think about organizing or breaking out species to their sensitivity. And so there's other issues that could be similar with other kinds of taxa as well. All right, another kind of aggregation is to think about how would you separate things out into core areas and then into things that might be more taxa-specific hotspots. Personally, I don't like the word hotspots because it's not really well defined, but that's what everybody uses, so that's what's on the pyramid here. And so what I want to do is talk through a couple of basic techniques for trying to say, well, where are these potential core areas? And so going back to our humpback whale example, if you look at a continuous map, usually what happens is the first thing that a policymaker or manager or somebody says is, okay, well, where's the core area? I'm looking at things from, cold colors being low densities to warm colors being high densities. Where's the hot spot? And immediately people look at the color ramp that you have and go to wherever are the warm colors. And where you set that threshold can be a fairly arbitrary decision on what's the threshold you would use for density to say this is some sort of core area or high density area or some definition. So we've got a lot of different methods that we've been throwing at this, and one I'm going to show you here is hopefully fairly intuitive, and that is to look at applying different thresholds of abundance. And so just to walk through this, if we took a map here that had the 99% threshold, and we often, just to note, we often use not 100% of the distribution because when you're doing maps like this with a predictive model, you may have some cells in the map that could have, predictions of densities that are 0.000001 or something, and so by just limiting it to 99% or some very small threshold gives you a more realistic map of the distribution. So here what we're looking at is for humpback whales, and we're looking at a presence threshold at 99%, 98%, so you can see even dropping 1% starts to narrow the area down, 90%, 75%, and then down to a 50% threshold. And so what we're doing in this, it's a little more complicated than just picking the thresholds. What we're doing is actually aggregating together cells that contain large numbers of these species and kind of sieving out the cells that are predicted to not have high densities. And Jesse wants to chime in on that.
Sorry, if I could just jump in here. One way of interpreting this map is to think that in the red areas on this map, we have half of the predicted population, and in the blue area, we have the other half of the predicted population. And so it really talks about how clustered the population is. And so we could say, the red area is the smallest area that we could define that has half of the population in it. So that's sort of the way that data is organized. We take the highest density pixels and kind of add those up until we get to these different threshold points.
So we found that this seems to be a fairly intuitive one, and we're hoping that it's fairly understandable. And that's one of the big issues we've been grappling with is we've come up with lots of different methods, and we're trying to pick ones that we can present not just to the scientific community, but then also to policymakers and managers to have them understand, what do these maps actually mean, what do they represent. So this is one possible way. What threshold you pick is, like I said, a fairly arbitrary decision, but it gives you a tool that we can go to, different kinds of cases and ask different communities. Okay, in this case, what kind of threshold would you apply to try to pick out a core area? Is a 50% number optimal or not? We use other methods to try to find out for individual species, and I actually cut those slides out of this talk, but we have methods that we can use to pick a more mathematical optimum for each species of what's the ideal threshold to use that captures the most numbers of the animals in the smallest amount of real estate. And that could be a different threshold for every species. The trade-off there is that index is kind of more, using that kind of method is more precise on a species-by-species basis, but then it's really hard to explain to policymakers and managers who are more comfortable with you saying, okay, here's a map of the 50% population areas for all species, for example. So the next kind of level up here is thinking about aggregations that are more generalized. So the last one I was showing was individual species at a time. The next map I have here, or three maps, show three different broad across taxa indices. One is total abundance, and then in the middle frame is looking at species richness, and then the lower right frame is looking at species diversity. And so total abundance is looking at combining all the marine mammal data together and getting animals per square kilometer. The richness is how many different species that you'd have, and then the diversity is using the Shannon Diversity Index, which is looking at species diversity and evenness combined together. And these are pretty different things to map, and the interpretation can be pretty different. We're hoping they're fairly intuitive in terms of what they represent. In the richness map in the middle, the legend there is actually just numbers of species, so going from 0 marine mammal species up to 32, which is the maximum overlaps that we have. And so what you can see is in that case, the shelf break is the area where you get the most species diversity of marine mammals, where you have the kind of convergence of the deep water, deep diving species on the shelf break, and then some of the shallow water shelf species that are on the other side of the shelf break overlapping. So that turns out to be, that ridge there is going to be the highest potential diversity along the whole Atlantic seaboard. One thing that we have found with different species data is that in addition to dealing with predictive models, there are other kinds of ancillary, more expert opinion maps that are becoming helpful, because models will tell you where you have abundance or density, but often don't tell you important information about usage. and life history. And so there is a whole series of maps that were just published this year that we helped out with that are looking at what they're calling biologically important areas. And these were expert-drawn polygons that show different important areas. So here I've got an example from New England where we have specific feeding areas, so feeding areas, breeding areas, calving grounds, things like that, that may or may not show up exclusively in abundance models, but are known by experts to be very critical areas. So we feel like these things complement each other very well. And this was just showing a map showing in the southeast with the North Atlantic right whale calving grounds in the southeast, and then the corridors going all the way up the coast. So the last thing here, as we kind of march up the pyramid, is thinking about multi-taxa. And so kind of went through one taxa with marine mammals, but with multiple taxa, we have to think about ways to combine them together. And so I didn't show any examples so far, but just to show you, here's one example from seabirds. And here we're looking at long-tailed duck. And on one side is abundance, the other side is uncertainty. So the seabird modeling that's being done by our colleagues at NOAA is fairly parallel to what I just showed for the marine mammals. For the fish species, they've stuck closer to the original data. So this is looking at products developed from the scientific trawl surveys. And so this is from the Northeast Fisheries Science Center, and Mike Fogarty's the lead PI from that group. And what they have is scientific trawl surveys, and here the one example we're using is Atlantic cod. And what we're looking at is biomass and interpolated biomass from those surveys for the different species. So when we try to aggregate the species together, there's several different approaches, and I'm just going to speak about one of them, what we're calling ecologically rich areas. Ecologically rich areas are a way to just try to combine the mammals, birds, turtle, and fish data together and into a single index. For the more physical features, the approach that we've been promoting is more of an ecological marine units approach, which lets you try to look at all the unique combinations of different features. So for the ecologically rich areas, we can create combinations or composites of different indices. So I showed you an example for marine mammals where we looked at species richness or species abundance. We can go and combine some of those together into composite maps that are abundance or richness or diversity of multiple taxa all combined. One of the issues with that is that when you do that, you end up with a single map that just shows total, marine animal abundance or marine animal diversity and shows those kinds of hotspots. But what can be lost in that is that you could have different combinations that give you different, equal hotspots. So you could end up in areas that have high abundance, but maybe it's different combinations of species. So one of the things we've been playing with right now, just to show you one little visualization, is just different ways to visualize these kind of composites together. And so the colorful map here is just showing an example of abundance hotspots, but looking at marine mammals, fish, and seabirds combined together, where we're using the different colors to represent the different combinations. So in this kind of example, you could have a hotspot that's a purple hotspot, and that would mean that's a place that's dominated by marine mammals and fish. Or you could have, a cyan or light blue hotspot that's a combination of fish and seabirds. And so it's a different way to be able to not only create these kinds of hotspot maps, but be able to try to visualize what are the compositions that make them up, and they could be different. So just to finish on this issue, as we start to go up this kind of chain, the different levels of analysis get more complex and more controversial. So you start out with basic distribution information and models. We then get into calculating abundance. We then end up having to come up with, critical areas. So those are things like those thresholds of saying where you have these core usage areas. And then when you get into vulnerability, people start to want to add in things like stresses on the system, habitat degradation, different kinds of vulnerabilities. And so the main point here is that there's increasing requirements on the data collection, and different approaches and more sophisticated analyses needs to occur as you kind of go farther and farther down this list. So that was the main kind of presentation I've got. I just wanted to end on one quick demonstration of an application, so just 2 slides here. In the Southeast region, just to show an example, we have a lot of new focus on energy leasing. And to look at this problem, we need to be able to bring together mapping on kind of the threats, so chronic noise, species densities that we just showed, biologically important areas, event noise that might be from seismic surveys or pile driving for wind farms or things like that, and then bring that together into marine spatial planning kinds of applications. So this is where we see some of these things heading in the future. I actually showed this slide last week to the director of BOEM and senior staff from BOEM, so we're engaged right now with federal agencies on how do we actually make this stuff useful. In the Southeast region, one of the things that is pretty critical is that if you go back and look at where we have proposed seismic surveys and other strong interest in areas for exploration, those happen to be some of the areas that we're showing are the highest diversity indices areas in the region. And so, this stuff is pretty relevant to a lot of applications that are kind of being considered at this moment in time. So I think I'll just end right there to give us at least a few minutes to answer some questions. So, Rua, do you want to take over?
Yeah, awesome. Thanks, Pat. So actually what we'll go ahead, I'll take any very quick questions for Pat and Jesse, and then what we're going to do real quick, we're just kind of going to go person by person, and just I want to get your thoughts on potentially using some of these models for improving the South Atlantic marine mammal indicators. So, just general thoughts, concerns, that kind of thing. So first, any quick clarifying questions with Pat?
Just could you go back to the last slide, if you don't mind?
This one here?
Yeah, that one. That's all. I just wanted to look at it, that's all.
Okay,
Thanks.
I was just trying to cruise through quickly here as we're running out of time. But
yeah. Okay. All right, so I'm just going to actually just go person by person, just taking your temperature, what your thoughts are so far, any remaining questions or concerns about potentially using this in an indicator. And I'm going to go in the order that I've got up here. So, Beth.
Yeah, I think it could be used. I don't have any questions or comments, but I do think this has a lot of potential uses for the indicator. So I think it's great.
Do you know?
Yeah, I think it's really good work. I'm impressed with all the work that's been done here. Looks really good, and I don't see any reason to have a concern about using it as an indicator.
George?
Yeah, I'd have to agree with everybody else. I think it's got just a tremendous amount of integrated data in it. It's very useful, and I'm sure Michelle can expand on this, but I think it's going to be very useful for planning some of the fisheries issues that we're dealing with in the Southeast in terms of long lines and fish traps and those kinds of things. So I think this will be very helpful.
Awesome.
Yeah, George, I would love to talk to you about some of those things. So maybe offline at another time.
Sweet. Jacqueline?
Well, I think I mimic everyone in saying, like, wow, what a great amount of work done in such a short amount of time. I do have one question on how sensitive this modeling is to change. So in terms of time scale, it's made from data collected over a number of years, and if, say, like the oil and gas industry ramps up in the Southeast, how could it be used temporarily to detect that change as if we are going to be, or as it's used as an indicator? Does that question make sense?
Absolutely, and great question. Right now, our big push was to get the most coverage possible and mine every scrap of data that we could get. And like I said, we already have an update that we need to be working on in the spring for the most recent surveys that we didn't have in hand. One thing we are considering is doing more longer-term temporal breakdowns, and part of this is because some of the data we're using is actually spanning a fairly long time period, and we have some issues to look at trends in the data, climatic trends. Do we still have the same oceanographic climatic regimes right now than data that might be 10, 15 years old? And so we are looking to see if we could start in the future breaking out more of the data into different time periods, and then also being able to use newer tranches of data as they come in to be able to do some comparisons. So that's something we're really looking at for kind of the next generation of work.
And if I could just add on that, we are interested even on a very much finer time scale as well. If there is monitoring that's happening for seismic or for other kind of real kind of intensive human uses, making the connection between this kind of information as context and that kind of, what you're seeing in a more immediate sense. And we actually have a little project with BOEM in the Arctic to kind of, use a kind of baseline level of information about who we're expecting to see at different times of the year to kind of marry in with a kind of monitoring and then kind of adaptive management kind of during some of these surveys. So, that work is kind of evolving, but we are interested in that really fine time step as well.
Great stuff, guys.
Thanks. Jessica?
I really like it. I think it's definitely an improvement from what we had last time, so I'm all for it.
Excellent. Mary Conley?
Hey, I agree. I think it looks great every time I see it. The presentation, there's more information that's been pulled in. And I think that idea of the trends in the long term and how to continue to update it, or even better understanding the Southeast, we saw that there were still, in terms of immediate data points that went into the model, some gaps, so how we can be supportive of helping to fill those, especially in that further off area that's being highlighted here, would be great for us to get behind.
Excellent. Great.
Just to let you guys know, that's one issue that we brought up with BOEM last week with the director of BOEM, was the need for more offshore and different types of data collection in the region, since there's a lot of usage that are being conceived of right now, and we have sparse data in some of those locations. So we're definitely hammering on the fact that we need better data collection in the Southeast.
Excellent. All right. Mary Trulio?
This is my first call actually joining in with you, so thank you for inviting me. I think this is extremely useful. I'm very excited to go back to my team. We are in the process of revising Florida's State Wildlife Action Plan. So it currently has 45 habitat categories and 1,036 species. So in our 2017 revision, this will be very helpful in updating our mapping effort and all our data gaps and so forth. So I'm excited to use this.
Awesome. Michelle?
Yeah, no, I just want to echo all the other great things that folks have said about this. This is also my first call seeing the results of this work, and hats off to Pat and Jesse for everything that they've done. And, I agree with George that there's certainly a lot of utility for some of the management issues that we're considering in the Southeast. And one thing that Pat said kind of stuck with me about decision makers often wanting to see more aggregated data, such as, any sort of combined diversity index year-round. And while I think that's useful for someone like me, a lot of the issues that we deal with are more species-specific. So I don't want to lose that. And I think particularly when you're considering, measures that have both a spatial and temporal component to them, I think that I wouldn't want to lose that specificity, I guess. So.
Excellent. Yeah.
Actually, just to comment on that, we've had that response over and over again in the work we've been doing in the Northeast and the Mid-Atlantic, and we keep trying to let people know that we're making all of the data layers available at the individual level, and any of the products, synthesis and indices and things that are done on top of that are just, additional products. Because I think people jump to the conclusion that, oh my God, you're aggregating everything together and we're losing that specificity. So I tell them that, it's more like thinking about there's going to be a library and there's going to be, rows in that library where you can go down and pull out all the individual volumes if you want, or you can look at the executive summary, and but I think it's an issue we need to keep driving home, is that people really do need to make use of the individual data, because that's where a lot of the detail is.
And I appreciate that, and I appreciate you saying that, because I would be concerned, given some of the large-scale activities, particularly that are being considered by BOEM, if it's only that highest layer of aggregation that's being considered, you might sort of write off potential impacts in another area. So thank you for that.
Cool. All right, I think Roy-Ying was having some technical issues getting on. Are you on, Roy-Ying?
Yes, I'm on. Thank you. Thank you, Ross. And I also want to thank Pat and Jesse for this wonderful presentation. One thing I want to mention is my team at NC State, we're running the high-resolution marine environmental models, covers Northeast, Mid-Atlantic, and also South Atlantic. So we provide essentially a 4-dimensional ocean circulation condition. So Pat and Jesse, I'd like to come over some points to look into potential collaborations with you guys, because I think we can provide higher resolution subsurface condition, and also you mentioned this region has a very highly complex ocean environmental conditions. That's something we probably can provide over a much higher spatial and temporal resolution.
Yep, we would love to do that, and I think this would be a great opportunity at this point. I think we're kind of at a phase right now where we've got this pulse of work. Actually, the journal article is going in this week and things like that, so we're really at a great point to start planning some new work. One thing to let you know, at the meeting we had with the BOEM director last week, Dave Eggleston was showing off some of your maps and talking about the resources that we have in the region. So your things are getting shown right in there already. So trying to work on that, 4-dimensional high-resolution modeling is something we would love to take into the future.
Wonderful. I'd like to stop by to visit you guys some point.
Okay.
Yeah, excellent. Okay, Tom?
Oh, I think it's fabulous. I'll just leave it at that. I don't think I have any position to affirm or approve. So I think it's just fabulous. Thanks.
Awesome. Well, thanks a lot. Sorry we went a few minutes over. I'll send a follow-up email. But basically the next step, so me and Amy and the group will keep working with Pat and Jesse and come back to y'all with a couple of specific options to sort of evaluate and look at for the indicator revision. And meanwhile, thanks a lot, everybody, and glad you could join the call. And thanks, Pat and Jesse, for doing some awesome work and giving us a good overview.
One last thing to mention, which I didn't, Jesse and I were kind of presenting all this stuff. Jason Roberts is our main modeler who's been working behind the scenes on much of this, so we try to protect him from having to do all these calls so he can work on models. And so the paper that's going to come out is going to be Roberts et al., and so I just want to make sure that we definitely give him kudos, because he's the one who's been doing the heavy lifting on actually producing these.
Heck yeah. Lots of kudos. All right, excellent. Well, thanks, everybody.
Thank you.
Thank you.
Thank you.